Hello everyone. Welcome to day 41 of learning data science. And we have completed with the Python. And today we are going to start with the EDA, that is exploratory data analysis. So, we will start with the things. And before starting with the actual, uh, what do you say, the actual code and all those stuffs, right? So, before that, we will discuss about the theory part, that basically in EDA, what it consists for. Okay. What do you mean by EDA? Okay. So we will discuss all these things. So I will open my spider and then we will start off with the things. Okay. So why to use spider again? Because there we can perform the same thing with the Jupyter notebook as well. But why spider? Again, spider, it's a beginner friendly and you can get a lot of things apart from visualization. Everything you will get it. And basically it suits for new users, for newcomers. Okay. And very it's simple to use. How to open a new file? Just go in the file section, open a new file here, and a new file will be generated. Okay, we will discuss about the EDA. What is EDA basically? Okay, we will discuss about EDA. Okay, we will be discussing about EDA. So basically, what's the full form of EDA? It is exploratory data analysis. Analysis. And behind EDA, what is the most important thing? That is statistics. You can't run from maths. If you are learning data science, you can't run away from maths. Behind EDA, if you will uncover the mask, basically, this is my face, right? And I'm wearing some mask, right? So that mask is EDA, exploratory data analysis. But behind that mask, it's real me. And what's real me? It's statistics, maths. Behind EDA, it's maths. One and only maths. And in maths, again, what? It's stats, statistics. Behind EDA, it's maths. Okay. Now we will move on to the next part. That in EDA, basically, in EDA, it consists of four parts. Okay. Only four things are there in EDA. And if you have learned all these four parts, sorry, basically, there are five parts. There are five parts of EDA, and you don't need much. You need only to, by heart, to understand these five parts only, and your EDA will be completed. Only five parts is there. Five things are there. You have to understand these five things. So, what is the very first thing? Very first thing is we call it first moment business decision. And what do you mean by first moment business decision? What do you mean by that? What do you understand by that? It's Measures of central tendency. And again, what is the measure of central tendency? You might have heard about. It's mean, median, and mode. So basically, these three things is only there in first moment business decision, which is measures of central tendency. And it's mean, median, mode. As I have said, stats, maths. Again, what is the mean? Mean, you can say it's the average, which is also equal to sum of all elements, divided by number of elements, total number of elements. Again, what is the median? Median is the middlemost value, middlemost values. And again, what is the mode? Mode is the highest occurrence of the data or data points. Okay. So for example, in mode is there, and just take a in a class. Okay. In a class, you have to search. You are looking that there are 30 girls are there and 50 boys are there, and total strength is 80. So what is the mode of that class? The mode of that class is boys. Why? Because highest occurrence of the data, which is of boys, not of girls. Okay. So mode here again, here means the highest occurrence of the data point, mean means average, median means the middlemost value. Okay. So here, first moment business decision means measures of central tendency, which is mean, median, and mode. So these all things obviously it comes under stats, but this is under EDA. So I have told you behind EDA it's maths, only maths. Okay. Now, what's the second thing? Second is second moment business decision. Again, in second moment business decision, what is comes? It comes measures of dispersion. I think these terms you might have heard in stats. What do you mean by measures of dispersion, right? So what is measures of dispersion? Again, measures of dispersion is the very first thing is variance. Second is standard deviation. Third is range. And again, what is range? It is max. It is max minus mean, which is called as range. Okay. And what do you mean by standard deviation? Okay. What do you mean by it? Just give me a second. Yeah. What do you mean by standard deviation? Standard deviation is a measure to check how my data points are dispersed from mean. Okay. For example, uh, say my mean is, for example, 5.5 mean is there. Okay. 5.5 is equal to my mean is there. And what are my data points? My data points are, for example, say 3 is there, 6 is there, 8 is there, 9 is there, 5.7 is there, 8.9 is there. These are all my data points. So what is standard deviation? Standard deviation is how my data points is dispersed from mean. Dispersed from means whether it's some high is there, low is there, it's uh, similar to mean, it's overlapping with the mean, or it is the dispersed to the right, left again it's high and low, and in the middle again it's mean. So it will show that how my data points are dispersed or scattered, how my data points are scattered with relevant to mean. Okay, here how it's checking with respective of mean. My mean is there. Okay, for example, uh, this is my phone. Okay, this is the mean. Okay, and let's take a 3D graph. This is a mean, and suppose my data point is here 1, here is 2, here is 3, here is 4. So how much it is dispersed from mean? What is the length? Again, don't consider saying as it length, because length will not be a good word, appropriate word. It will be how much it is dispersed, whether it is dispersed through like this, right, left, up, down, how it is dispersed from mean. That particular thing is known as standard deviation. And again, what is the variance? Variance, you can say it's the square of a standard deviation. Okay, that is basically, you can say it's the square of standard deviation. Again, why we are taking the square? We are taking the square to remove the negative values. We can also take modulus, but yeah, we are taking variance here. So standard deviation means how my data points are dispersed from mean. And variance, again, it's the square of standard deviation. And what is the range? Range means max and min. What is my maximum value inside a mean? What is my minimum value? Sorry, what is my maximum value of my data points? Uh, Here you can see my maximum value was 9 and my minimum value was 3. So what's the range? Range is 6, max minus min. So it's the simple term range, that is max minus min. And tomorrow we will discuss upon the formulas of this variance standard deviation range. We will discuss about that also, but not now, tomorrow. Today we will be discussing about what are the 5 parts in a theoretical way, and then we will discuss it one by one. First we will go with first moment business decision, what is the formula, then we will go with second moment, then we will go with third moment. Okay, now what's the third? Third is, that is, third moment business decision. Okay, and what comes under third moment business decision, it's known as skewness. Okay, and what do you mean by skewness by the term itself? I'm not asking in the term of Python or EDA. No, I'm asking in the term of simple English language. What do you mean by skewness? What do you mean by skew? Okay, so you might have heard, means like, for example, uh, this is a balloon, right? This is a balloon, or say, for example, this is my charger, right? This is my charger, and now you can see it's not in a tension mode. Okay, I am just using like this. Okay, it's just being in a circular or scrambled form, right? So now I'm screwing it, I'm stretching it, and after stretching I see that this is a straight. There is no curve in between. No skewness is there. No skewness is there means this is my perfect wire. Why perfect wire? Because this is straight, and if some skewness will be there, then similarly some bend will be there. Okay. So in simple word, just assume bend. Okay. So no bend is there in my this charger, my USB cable. So this is my perfect cable for it, and it will charge my phone appropriately. You can see no bend is there here. So skewness, it will show that how our data points is there. The graph, it will show how our data points is there. Okay. So for example, let's take an example to explain you guys in a much better way. Okay. So what I will do, um, I will just execute this line of code. Okay. Here I will show you the skewness. Here you can see these are my data points. And if I will just put a line like this, a thread like this, so what you will see, my thread is becoming thinner here. Here is a height and it's becoming thinner here. Okay. Uh, yeah, thinner is there. I will just open my zoom here so that I can just explain where is my zoom. Yeah. I will stop sharing here and I will just open my whiteboard. Okay. Yeah. So here you can see I had talked about the skewness. Okay. Skewness. Okay. What do you mean by this particular term skewness? Okay. So you have seen here, this was my graph. This is my x-axis. Again, uh, this is my y-axis. This is my x-axis. Okay. So if my graph will be like this, like this, like this is there. So you can see here at some point of time, here my data is skewed. Okay. What is there? My data is skewed. My data is skewed. Why it is skewed? Because you can see The skewness means like it's bending, it's bending towards like this. It's not normal. How you can say a normal graph? You can say a normal graph like this. X-axis, Y-axis is there, and my graph is like this. If my graph is like this, then you can see there is no skewness here. No skewness is there here, right? But what if my graph will be like this? Like this, my graph is, right? So you can see here some part of data is skewed. Some part of the data is skewed here. Okay. Some part of my data is skewed. So skewness means when we will look at the graph, we will see where my data points, because these all are the data points, right? Here is the data point, here some data point is there like this, like this. For example, this is you can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So like this, my data points are there. Similarly, here you can see one is there, two is there, three is there, right? Here you can see four is there. Again, here you can see five is there. Okay. Here you can see again six is there, seven. So similarly, you can see my data points are there, and I have plotted this graph according to my data points, right? So basically, when my value of x was 1 here, similarly my value for y was 1. When it goes for 2, it's somewhere around 2.5. When it's for 3, it's somewhere around 3. When it's 4, it's somewhere around 4.12, right? So like this, the graphs are there. And here you can see when my value of x was 6, my value of y was 1. So what does it mean? It means that my data points are skewed towards the right, right? My data points values was skewed towards the right. It's not a simple graph, means like we were plotting it. So what do you mean by skewness? Skewness means if my graph is bending towards something, is bending towards, or you can say in a simple word, it's that it's not normal. You can say this graph is not normal because these are all my data points itself. If these are my data points, how this is normal? How these things is normal? No, it's not normal. Okay. So I will again share my screen to the this Python. Okay. And here also you can see it that my data is skewed here. If I will draw a line, you can see some data points are there here, and it is skewed like this. It is skewed like this. My data points, it's skewed. So we will discuss accordingly why skewness is there. So first, I might you have understood about what is skewness, okay? And what is the fourth? Fourth is kurtosis. And again, what do you mean by kurtosis? Kurtosis means uh, it shows It shows the peakness of the graph. Peakness here again means what? Peakness means, okay, peakness means, for example, this is my graph, this is my graph, x-axis, y-axis, and for example, my graph is like this. You can say this is my x and my graph is like this. So you can see here there is certain peakness. Okay, if it's like this, then you can see the peakness is there. So basically, kurtosis, what do you mean by kurtosis? Kurtosis means kurtosis means it determines the peakness of our graph, or you can say the peakness of the data points. Okay, so that particular thing means kurtosis. We will learn in detail what is basically kurtosis, right? So for just now, understand these things. Kurtosis is the thing. And what is the fifth? Fifth is graphs. Graphs again here, you can see here in my this file, you can see here, for this you have to import two things, that is matplotlib and seaborn. Okay, so for graphs you have to learn 5.1, you have to import the libraries matplotlib. Matplotlib is you can say for basics visualization, and 5.2 here you can see seaborn. Seaborn is for advanced. Okay, so these five things are only there. So these five things are only there in EDA. When we discuss about EDA, in EDA it consists five parts. First is business moment, business decision. Second moment, business decision. Third moment, fourth, and fifth is graphs. So when you have understood all these things, all these five things, your EDA will come to an end. At the end, donkey ki chot pe, you can say that you have completed the EDA. And EDA consists of only these five things. You have to master these five things: mean, median, mode, variance, standard deviation, range, skewness, kurtosis, and graphs using the libraries of Python, Matplotlib, and Seaborn. Okay. So I hope you have understood these things, my EDA. Tomorrow we will discuss step by step. First moment business decision, second moment business decision. We will discuss step by step. And till then, you guys just keep practicing it, at least 100 lines of code every day. And see you tomorrow. And till then, goodbye. Take care. Jai Hind.